Hey everybody, I hope you're doing well. In this video, I want to talk a little bit about the bicycle problem. So, the bicycle problem comes from related rates too, and it starts off with you have two people on bicycles, and they're separated east and west by 350 meters. Person A starts riding north at a rate of 5 meters per second, and 12 seconds later, person B starts riding south at 3 meters per second. The question is, at what rate is the distance separating the two people changing 2 minutes after person A starts riding? So, in order to do this question, we need to have an idea about how these people are related to each other. So, I am going to start with an east-west line that's 350 meters. Person A, person B will be traveling in different directions. I'll label this with an A and this a B. I know this distance here is changing, so I am going to call this x of t. I know this distance is changing, so I am going to call that y of t. The question is relating the distance, or I should say using the distance between A and B. So the hard thing about this problem is to come up with a model. One assumption that is usually made, which is wrong, is that this intersection point right here is a midpoint, and that is actually not correct because these two distances are going to be different most of the time. So how do we actually generate a model for this? Well, one way to do this is to take this distance, this length, and transpose it over here. I'll connect this up with a horizontal line, and now I know this distance is also y of t. So my model for this is a Pythagorean model. Specifically, it's x of t plus y of t squared plus 350 squared is equal to, well, this is the distance that I want to look at, z of t squared, and I think I missed one parenthesis right there. So there's my model. So what's given and what do we want to show? Well, in the problem, let me go back really quickly and read it again. It says person A is riding north at 5 meters per second and person B is riding south at 3 meters per second. So I'm going to write that down in terms of some derivatives here. This says x prime of t is equal to 5, y prime of t is equal to 3. Even though they're going in different directions, both of the derivatives are positive because x prime of t is measuring this distance. And is this distance getting larger? Well, yes, it is. Is this distance getting larger? It's also getting larger. So therefore, both of these are positive. And, oops, sorry, my bad, this is the given. Don't know why I did that. And I want to show z prime of t. Sorry about that. So now we have to take a derivative of the model. Taking a derivative of this, I need to use a chain rule. So I am going to drop the power, leave the inside alone, subtract 1 from the power, I won't put a 1 there because it looks like a prime, times the derivative of the inside. I just used the sum rule, is equal to, I'm not going to have enough room here, the derivative of 350 squared is 0. The derivative of z of t is z times z prime of t. So z squared, drop the power, leave the inside alone, take the derivative of the inside. So what are the things that we know in this problem? Well, we know x prime We know y prime, that's given right from here. But we do not know x and y. But in the problem, it tells us something about when things start. So let's read it again. Person A starts writing at a rate of 5 meters a second, and 12 seconds later, so person B is writing for 12 seconds less, is writing at 3 meters per second. Person A has been writing for 2 minutes, but person B is 12 seconds less than that. So I'm going to try to write that down over here. So what do we know? I want this to be done at 2 minutes. So what is x at 2 minutes? Well, travels at 5 meters per second, per minute, and that's equal to 120 seconds. I think I might have said 5 meters per minute. That's 5 meters per second. Y of 2, well, travels at 3 meters per second, but doesn't travel for 120, travels for 8 seconds less. So I wind up getting two numbers here. This is 600 meters, and this is 3 times what? 1, 1, 2, which looks like 336. And these are both in meters. I'm going to do one more calculation, and then you're going to have to solve the rest. From here, I can wind up getting z. X plus y, 600 plus 350, 336. I got to copy this. Squared plus 350 squared is equal to my z of 2 squared, because t is equal to 2. You need to solve for z of 2. Then you need to take all of these values. I will have this value, and this value after you're done with this. And you're going to eventually solve for z prime of 2. That's the majority of the problem. I hope that was helpful. And we'll talk about this in class. I'll see you later. Bye.